Good afternoon, everyone. I'm Alex Beluka, and I would like to welcome you to this February webinar organized by the EPSRC Network Plus for the decarbonization of heating and cooling. So be welcome, make yourself comfortable. My name is Alex Beluka, and I work at different aspects of the thermal energy conversion, majoring in combustion. The purpose of the network is to look at the different challenges of decarbonizing the heating and cooling sectors and behaviors. This month, we will have two speakers who are leading investigators of the projects funded through EPSRC Decarbonizing Heat. We're very happy to have them here and thank them for their time. And right now I would like to pass the word to Professor Patrick James, Professor of Energy and Buildings at the University of Southampton, who will present the findings of the LATENT project. Professor James, the word is all yours.
So this project is midway through, so we're really sort of giving you an overview of what we've done so far. Some interesting challenges that we never anticipated, or I didn't anticipate would actually occur in this project. My colleague Tom Rushby is actually on this call, so I'm teaching it too, so I may have to run before the end, in which case I'll trust Tom to answer any of your questions. So this project is a research partnership with a company called Good Energy, and we're looking at the idea of using the thermal capacity of a house as a way of deferring heat demand going forward in an electrified heating system where we all have heat pumps. The program is essentially split into 4 blocks. So work package 1, the top left-hand corner, we need to understand, would people accept a third party, such as a company, actually remotely turning off their heating system to protect the electricity network when it's under stress, to reduce that peak? Would people actually accept that in their home? Work package 2, what's actually the thermal capacity of the building itself? How many minutes or hours can we actually gain in terms of deferral? And how does that vary with the type of house? You know, if you live in a flat or if you live in a castle, what's the difference in terms of the number of minutes you can achieve? Work package 3, crucially, what's the value to the electricity network? Is it the wider network, or is it at the individual substation level? And can you monetize that as a value, and a value which you can then pass on to the customer as perhaps a change in their tariff? So that's what we're looking at. Would people accept heat deferral by a third party, by a company? What's the thermal characteristics of their home? How does that help you? How does that support the electricity network? And what's a financial model which works for the network operator, for the energy company, and for the householder? The government is, as you all know, aggressively pushing air source heat pumps as a solution, but the takeoff is much slower than perhaps they were hoping. Yes, there are support schemes in place, but take-up is not as quick as the government certainly would like to see, I think. But conversely, the energy tariff network is moving quite quickly in the UK. So, for example, Octopus has a tariff where they reduce their price before the evening peak, but if you choose to use electricity in the evening peak, you pay a premium for it. So this really represents what would happen if you operate an air source heat pump. You would perhaps overrun your heat pump mid-afternoon, heat the house, heat the hot water, and then don't run your heat pump in the afternoon, early evening, to protect the electricity network. So this is what we're trying to understand. Would people actually accept this? with a third party taking control of your system. So we were working with Igloo Energy. They had around about 130,000 customers, and about 20,000 of those customers consented to share data around the makeup of their home, the thermal properties of their home, which was undertaken via a survey called Me and My Home. So we had about 27,000 customers with this survey, and a subsequent 20% of those were in a pool where we were able to undertake studies with them. And we asked them questions such as, would you approve an energy company to remotely control your heating system? And you can see here that most people either disapprove or strongly disapprove. So it looks like we're in trouble as a project. Most people don't seem to like the idea of us controlling their heat pump. And then we asked them, what would you think you'd accept as a level of temperature drop in your home if we control your heating system on a scale of 0 to 5 degrees? And you can see that most people are only accepting the light grey is no temperature drop at all. The light yellow is up to 1.5 degrees temperature drop in the home. And in most cases, that's the majority. And in the evening, which is where the network is under stress, you can see 80% of households said the most they would accept would be a 1.5 degree temperature drop. So it looks like we have a lot of work to do to be able to run heat deferral as an option. So we've been undertaking focus groups with this customer pool to understand what are the barriers, what might have to change, how can we convince people that heat deferral is a good approach to take. And if we explain this technology and why this benefits the network, perhaps we can convince people to change their perspectives. So on the left, these are a customer pool, and we run a workshop event with them where we show them videos, we run some polls and explain the idea of heat deferral, why that's important, and what we can deliver using this technology. The dark blue down the bottom, these are customers who are really not keen on heat deferral, and they don't change their view. So there is a certain slice of our customer base even when we go through this process, they don't change their perspective. But you can see the light blue and the light pink, these are moderately acceptable or moderately negative. They move towards the yellow, which is higher acceptability. So when we run these focus groups, you can see the gradual movement from bottom left towards the middle and top right. So when you explain heat deferral as a principle, we can see that more of our customers say that they would be accepting of this approach now that they understand it. So educational awareness is clearly very important. Now, I'm sure you're aware that multiple energy companies went bust over the past 2 or 3 years, one of which was our industrial partner in our project, Igloo Energy. And so we are now working with their heat pump division called Igloo Works, who have recently been taken over by Good Energy. So we've actually moved partners effectively twice during this project. So it's a good bit of learning for any of your projects to be aware about risk with very large subcontracts and what might go wrong if your partner ceases trading. So we are now working with a heat pump provider, and we are actively controlling heat pumps in people's homes. This is a blind study. We do not tell the participants we are going to when we turn their heat pump off, but we do give them an app they can use where they can call for heat on their system if they believe that we have turned the heating system off and they are feeling cold in the home. We also set minimum temperature thresholds. If the house is below a certain level, we will not turn the heating off in their home, for obvious reason. So at the moment we have 30 heat pumps where we control their heating system remotely, and a further 30 heat pumps where we observe but we don't turn those heat pumps off. So we have a longitudinal control intervention study. You can see it's dominated mostly in the southeast of England. Here's some data from one of our deferral events on the 10th of February this year. So you can see in this middle region here, we ran a heat deferral event from 5 p.m. to 6 p.m. So the blue lines represent those heat pumps where we're actively controlling them. The dark blue fat line is the average of all our participants. So you can see the average heat pump power up to the deferral event was around about 1 kilowatt. Then it drops down to essentially 0 and then returns after the heat deferral event. The excluded ones represent heat pumps where the temperature in the house was too low, so we were not allowed to turn the heat pump off because it was below what we decided was a minimum threshold of 18 degrees C. So you can see visually that the heat deferral approach is working here. We turn people off and we don't see any evidence of them all overriding the system and coming back on straight away. This is the temperature decay in all of the households. So if we take the 0 to be the point when we turn the heating off, here the temperature would have dropped 1 degree within a house within 1 hour. And none of our households dropped by 1 degree during this period. And we don't see any evidence of overriding here, so probably these people are accepting of this level of heat deferral, 1 hour and less than 1 degree. Interestingly here, this is the hot water supplied by the heat pump. And we've noticed that when we turn the heat pumps off in terms of delivering heat, the strategy of these heat pumps is, oh, okay, I've been told I mustn't deliver heat. I'll now deliver hot water. And so you can see they cut in to deliver hot water because we've turned off the heating mode. We are now switching these two things off together. Because obviously we're looking at protecting the network. We don't want to suddenly turn the heating off, but then all the heat pumps start working in hot water only mode. We want to turn off both options. So now we run deferral events where we turn off heating and we turn off the hot water operation together. We asked people via survey over the past 2 weeks. We've conducted some heat deferral events. How many do you think we have undertaken? So in this case, we'd actually undertaken 4 heat deferral events up to a max of 1 hour. Over half our customers didn't notice any heat deferral events. So the ones in yellow, these responses were estimating how many there were. Most people thought there were 2 heat deferral events. They thought they were between 30 minutes and 60 minutes long. And almost everyone said they didn't notice a change, or they noticed a change, but everyone was accepting of it in the house. So this is all very encouraging. It looks like you can run a heat deferral event. People either don't notice, or if they do notice, it doesn't bother them, which is great. We suspect that actually people are more likely to notice the lack of hot water, and actually that may be what might annoy them first. So we are currently testing, going forward, moving this to 2 hours, this heat deferral event, both heating and hot water, to see if people notice, or whether actually taking the hot water off for 2 hours in the evening is actually what people concerns them. And therefore, maybe you have to preheat the tank before a deferral event, perhaps, to stop that issue. So going forward, we anticipate a rapid growth in our customer pool. We are running trials both this heating season and the next heating season. We think we'll be at 150 plus participants in our trial going forward. We'll be testing various heat tariffs and mechanisms and modeling how, when you aggregate this effect across the building stock and around a substation, how that will support the network going forward. That concludes my talk. I hope that was of interest. Thank you.
Again, I would like to thank Professor James for very interesting talk and for very impressive timekeeping.